have our neuromuscular junction, an area where the somatic motor neuron meets up with the muscle fibers. Here we have our axon terminal. It's the end of the neuron at the neuromuscular junction. We have our voltage-gated calcium channels. We have our ligand-gated sodium channels in our synaptic vesicles and our synaptic cleft.
The next step is excitation-contraction coupling. It starts off with action potential opening up the voltage-gated calcium channels, allowing the calcium to connect to the vesicles, causing the acetylcholine to drop down past the synaptic cleft, attaching to the ligand-gated sodium channels.
The next step is the sodium goes into the T tubules. Since they're both positive charges, the sodium pushes the calcium down. The calcium attaches to the troponin, pulling the tropomyosin out of the way of the actin, and now the myosin and the actin can power stroke and be able to contract.
The next step would be muscle relaxation. So nerve stimulation stops, meaning that acetylcholine is no longer traveling into the synaptic cleft. And then also acetylcholine will unbind from the receptors. Acetylcholine esterase will then start to eat the acetylcholine. Calcium will then unbind from the troponin on the thin filament, causing the tropomyosin to shift over to cover the myosin binding sites. And also the calcium will start to push out the sodium into the synaptic cleft. And the myofilaments, the actin and the myosin, will start to walk back into the resting position.